Over the years, scientists thought they knew it all. However, to their dismay, there was still much more to explore. Some of the simplest things we have access to in life today, such as GPS, wouldn't have existed if it weren't for all these great scientists who made many life-changing discoveries and invented countless essential inventions. The reason we know all these scientists' names and glorify what they've done is that some of their theories have had a great impact on us to this date. Some of these important theories are the Brownian motion theory, the theory of relativity, and the quantum theory. The Brownian motion is the motion of particles in a liquid. This theory proved the existence of atoms and that solid atoms are compacted, liquid atoms are far away from each other, and gas atoms are scattered further apart. Max Planck worked on entropy, and after he came up with his results, he found out that J. Willard Gibbs has already done something similar to his work. Entropy is a thermodynamic property that can be used to determine the energy available for useful work in a thermodynamic process. It's basically the amount of disorder within a system. For example, if we have water frozen in an ice cube, this ice cube has a structure since the molecules are held together. If we let this ice cube melt, it will gain entropy and lose the order and structure it had. The ice cube will then become water with more energy, motion, and disorder, which means that there is an increase in entropy. Michelson and Morley unintentionally weakened the belief in something called the ether, which is a stable, invisible, weightless, frictionless, and imaginary medium that was thought to permeate the universe. The ether was a way to explain how light travels across the emptiness of space. Morley and Michelson conducted an experiment that falsified Isaac Newton when he said that the speed of light differs depending on whether we're moving towards it or away from it. Michelson and Morley's experiment results showed that the speed of light is constant, and it also verified what Kip S. Thorne stated. Thorne said that the speed of light is the same in all directions and at all seasons. Michelson and Morley's experiment plays an important role in the theory of relativity, since the most fundamental principle is that the speed of light is constant.
The equation E is equal mc squared.
The second theory is the theory of relativity, which was created by Albert Einstein. The equation for this theory is E equals mc squared, in which E stands for energy, m stands for mass, and c stands for the constant speed of light. The following video is an example that explains the theory of relativity.
Suppose there's a truck moving down the road at a constant speed of 50 miles per hour. On the back are a baseball pitcher, a catcher, and their pitching coach, armed with a speed gun. As long as the truck doesn't speed up or slow down or hit any large bumps, they can conduct pitching practice just the same as they would on the baseball field. And when the pitcher throws a 100-mile-per-hour fastball, the coach's speed gun will read 100 miles per hour. The ball is indeed moving 100 miles per hour relative to the pitcher, the catcher, the coach, and the truck. But suppose an observer standing by the side of the road clocks the speed of that same baseball. What speed would this observer measure for the ball? Well, the ball would already be moving at 50 miles per hour when the pitcher was just holding it. So this observer would measure a speed of 150 miles per hour for the pitch. The speed of the ball relative to the truck, plus the speed of the truck relative to the observer.
Finally, Planck and Einstein worked on a theory called the quantum theory. However, both of them came up with the same concepts at different times, which shows that scientists back then didn't communicate. The quantum theory showed that everything that moves contains energy, and this energy can be calculated. Finally, the purpose of this video can be summed up in Taha Hussein's quote, which says, "The end will begin when seekers of knowledge become satisfied with their own achievements."